Hey everyone, welcome back. We'd love to take deep dives into the latest LLM research, and today we're going to be talking about making LLMs faster.
Yes,
And
exactly.
we're going to be focusing on this idea of lossless acceleration,
That's it.
where we can get better inference speeds without having to sacrifice the accuracy of the model.
Yeah, and specifically we'll be taking a look at this new paper on hierarchy drafting,
Oh yeah, hierarchy drafting.
which
Okay.
is a really cool way to improve the speed of speculative decoding.
Okay, so speculative decoding, that's something that I think some of our listeners may not be super familiar with.
Right.
Can we just take a quick step back and kind of explain what speculative decoding is before we dive into this whole
Yeah.
hierarchy drafting idea?
Yeah, so speculative decoding, it's kind of like how we write drafts before finalizing a document.
Okay.
LLMs can actually use these like draft tokens to predict what words are likely to come next.
Okay.
And the really cool part is these drafts are then like checked against the LLM's actual output.
So it's kind of like a double check.
Yeah, it's like a double check exactly, and this allows for multiple tokens to be generated at once.
Oh, so that's where the speed improvement comes from.
That's exactly where the speed improvement comes from
Oh,
without actually sacrificing any accuracy.
got it.
It's a win-win situation.
So you can generate multiple tokens at the same time without losing any accuracy.
Right.
I mean, that sounds great.
It does sound great.
But I know you mentioned something about database drafting earlier and some limitations.
Oh, right. Yeah. So to create those draft tokens, most existing methods kind of rely on just a single data source.
Okay.
So it could be like previous text that the LLM has seen, or it could be just a giant collection of writing, or even tokens from another LLM.
Mm-hmm.
But here's the thing: the performance of this single source can be inconsistent.
Okay. Yeah, I could see that how.
Sometimes it's great, sometimes it's not so much.
Yeah, like it's not reliable,
It's not
basic.
reliable, yeah.
Okay.
It's kind of like trying to bake a cake with only one ingredient.
Yeah, some cakes only need one ingredient.
Well, yeah, but most of the time.
Right, but most of the time that's not going to turn out so well.
Right, you need a little bit more than that.
Yeah. Okay, I like that analogy.
Yeah, so that's kind of where this new method hierarchy drafting comes in.
Okay.
It kind of saves the day
Saves the day.
by addressing that inconsistency by being smarter about where it gets those draft tokens from.
Okay, I am intrigued.
Yeah.
Tell me more about this hierarchy drafting. How does it work?
So instead of just relying on one source, hierarchy drafting, or HD,
Uh-huh.
it organizes draft tokens into three separate databases
Okay.
based on what we call temporal locality,
Temporal locality.
which is a fancy way of saying how likely a token is to appear based on like the recent conversation or task
Oh, okay.
that the LLM is working on.
So it's almost like you're looking at like different levels of notes.
Yes, exactly.
You got it. Like you've got your cheat sheet for your specific task, and then you've got your general study guide for the subject,
Right.
and then you've got the massive textbook that covers everything.
Exactly. And HD is smart about knowing which notes to check first.
Okay.
To find those most likely next tokens.
Like I'm starting to get the picture here.
Yeah.
So what kind of information goes in each of these databases?
Okay, so let's start with the context-dependent database.
Okay.
Or DC for short.
Okay, DC.
This is where we store those tokens that are like super relevant to the current conversation or task.
So it's like your hyper-focused cheat sheet
Yes,
for
exactly.
the specific problem in hand.
Yes, like let's say the LLM is working on a math problem and it has some specific coordinates in it.
Okay.
Those coordinates are likely to appear again, so HD would stash those in DC
Okay.
so it can access them very quickly.
So super relevant in the moment tokens.
Yes, very much so.
What about the second database?
Okay, so the second one is called the Model Dependent Database, or DM.
All right.
And this one captures those phrases that LLMs just tend to use a lot,
Okay.
regardless of the context.
Right.
So things like, as an AI, or based on the information provided.
Right.
Those kinds of things.
It's like the LLM's catchphrases.
Exactly. It's like their little phrase book.
Got it. So DM is like the LLM phrase book.
Yeah.
Full of those familiar expressions.
Yes.
And then what about the final database? This is where things get really interesting. Right?
Yes. This is where it gets really interesting.
So we've got these three databases, each with a different level of specificity.
Right.
But how does HD know which one to check first?
Right. Yeah, that's a good question because it seems like jumping between all these databases could actually slow things down.
Yeah.
But that's where HD's like secret sauce comes in.
Mhm.
It's this hierarchical approach.
Okay.
So it starts by checking the most relevant database, right?
Mhm.
That DC for those hyper-specific tokens. And if it doesn't find what it's looking for there,
Okay.
It moves on to DM, the LLM's phrasebook.
Okay.
And then finally, if it's still searching, it goes to Ds.
So it's like it's prioritizing its search. It
Exact.
starts with the most likely candidates
Right.
and then only expands out if it needs to.
Exact.
I mean, that's pretty smart.
It is smart.
But does it actually translate to real-world speed improvements? Like,
Yeah.
does this actually make a difference?
Oh, yeah. It definitely makes a difference.
Okay.
The researchers actually tested HD with a bunch of different tasks and LLM sizes.
Okay.
And the results are really exciting.
Okay.
For example, they tested HD with Llama 2,
Uh-huh.
which is a pretty popular LLM these days.
Yep.
And in one scenario, HD was able to generate text like a whopping 64% faster
64% faster.
than standard methods.
I mean, that's huge.
Is a big improvement.
Wow. Okay.
Yeah.
I'm curious, did they find that like certain databases were more effective for different types of tasks?
Oh, yeah, for sure.
Okay.
The best database really depended on what the LLM was actually doing.
Okay.
So, for example, for tasks like multi-turn conversation
Okay.
and summarization, DC really shined.
Okay. So that hyper-focused cheat sheet was really helpful.
Exactly, yeah. And it makes sense, right?
Yeah.
Because those tasks, they rely heavily on like recent inputs and context.
Yeah, totally.
Like if you're summarizing a news article,
Right.
those key terms and phrases are going to be repeated a lot.
Right.
So having those readily available in DC makes things super fast.
Okay. So what about tasks where the context is a little bit less repetitive?
Right.
Like something like translation or answering factual questions.
Yeah, so in those cases, HD kind of shifts gears a little bit,
Okay.
and it relies more on the model-dependent and statistics-dependent databases.
Okay.
So DM and Ds,
Got it.
because they provide a wider range of language patterns and general knowledge.
So it's kind of like HD has this ability to adapt
Yes,
to
exactly.
whatever the task
It's
is.
very adaptable.
And it's choosing the right approach based on what it's doing.
Yeah, it's like it understands what kind of language is needed.
It's amazing.
It was pretty cool.
Okay, so it sounds like HD is really pushing the boundaries
Mm-hmm.
of what's possible with LLM efficiency.
Yeah.
But I have to ask, are there any limitations?
Well, like with any new technology, there are always areas for improvement.
Sure.
One thing to keep in mind is that HD's performance is tied to the quality of those draft token databases.
Okay.
So if the databases are missing information or if they haven't been trained on a specific type of language,
Uh-huh.
HD might not be as effective.
Okay, so it's only as good as the data that it has access to.
Pretty much, yeah.
Got it.
And that's why researchers are always working on expanding and refining those databases.
Right, making sure that they cover
Right.
all the different types of language and knowledge.
Exactly.
Okay.
It's an ongoing process.
So it's not like a perfect solution,
Right.
but it's definitely a step in the right direction.
Definitely a step in the right direction.
I'm curious about the computational side of things.
Yeah.
Does maintaining these three databases require a lot of extra processing power?
That's a really good question.
Yeah.
And surprisingly, the answer is no.
Okay.
HD is actually pretty lightweight
Okay.
when it comes to computational overhead.
So it's not like I need to upgrade my whole system
No, not at all.
just to implement HD.
No, you get all those speed benefits without having to sacrifice performance.
Wow, that's great.
Yeah.
So it makes it a lot more accessible
Yeah.
for people who are working with LLMs on a regular basis.
Exactly.
I want to kind of shift gears for a second and think about the bigger picture.
Okay.
How do you see HD shaping the future of LLM interactions?
I think HD has the potential to really revolutionize the way we interact with LLMs.
Okay.
Yeah. Like, imagine a world where those frustrating delays and loading times are a thing of the past.
Right.
You know, LLMs could respond to us in real time.
Uh-huh.
Conversations could feel way more natural and fluid.
It would.
It would be a game changer.
That's a really exciting vision.
It is.
With that increased speed and responsiveness, I mean, we could see LLMs becoming even more seamlessly integrated
Right.
into our daily
Yes,
life.
exactly.
From lightning-fast chatbots to real-time translation tools.
Yeah, the possibilities are pretty much endless.
Endless. Okay, but before we get too carried away with the future predictions, let's bring it back to the present for a second.
Okay.
For someone like me who's learning about HD for the first time,
Uh-huh.
What are the key takeaways?
Okay, so first and foremost, HD offers a really practical and powerful way to make LLMs faster without sacrificing accuracy.
Okay.
And it does this by using these readily available data sources
Uh-huh.
and this clever hierarchical approach.
Okay.
So no need for like complex retraining or fancy hardware.
Right. That's great news.
Yeah,
And it sounds like HD is more than just a simple speed boost.
right.
It's really a testament to the importance of adaptability in LLM design.
Exactly.
Like HD is showing us that LLMs need to be flexible,
Mm-hmm.
responsive to different types of language and tasks.
Yeah, it's a prime example of how these innovative approaches to data and algorithms
Uh-huh.
can lead to these really significant breakthroughs in LLM performance.
And this is just the beginning.
Yeah, just the beginning.
As research in this area continues,
Right.
we can expect to see even more impressive advancements.
Absolutely.
This has been a really enlightening deep dive.
Yeah.
But before we wrap up this part, I have one final question.
Okay.
We've talked a lot about the benefits of HD.
Uh-huh.
Are there any potential downsides or ethical considerations?
Yeah, that's a really important question.
Yeah,
While HD itself is a purely technical advancement,
right.
it's crucial to remember that any technology can be applied in ways that are both beneficial
Uh-huh.
and potentially harmful.
So the ethical considerations lie in how we choose to implement it,
Exactly.
rather than any inherent flaws in the technology itself.
Right. It's up to us as developers, researchers, and users of this technology
Uh-huh.
to ensure that HD is used responsibly and ethically.
Okay.
We need to be mindful of the potential impact
Yeah.
and strive to create a future where LLMs are used to benefit humanity as a whole.
That's a powerful reminder that technological progress must always be accompanied
Yeah,
by a deep consideration of its potential consequences.
absolutely.
It's up to all of us to shape the future of LLMs
Uh-huh.
and ensure that they're used for good.
Well said.
Well, on that note, I think it's time to wrap up part 2
Okay.
of our deep dive into hierarchy drafting.
Sounds good.
In part 3, we'll explore some real-world examples of HD in action,
Yes.
and we'll delve into the exciting possibilities
Yeah.
that this technology holds for the future of LLM interaction.
Looking forward to it.
Stay tuned. Okay, so we're back for the final part of our deep dive into hierarchy drafting, and I'm always excited to see how these cutting-edge techniques
Yeah.
actually play out in the real world.
Right.
So are there any specific examples of HD in action that really showcase its capabilities?
Yeah, absolutely. The research paper actually included some really cool case studies
Okay.
that kind of bring HD to life. And
Yeah.
they focused on two very different tasks. So
Okay.
question answering
Okay.
and retrieval augmented generation.
Okay, yeah, so question answering is all about finding specific answers,
Right.
and RAG is about generating creative text
Right.
based on some source document.
Exactly.
So how did HD perform in these very different scenarios?
Well, that's where things get really interesting.
Okay.
For question answering,
Uh-huh.
HD really favored the model-dependent database.
Okay, DM.
Yeah, DM. Remember, that's the one with all those classic LLM phrases?
Right, based on the information provided.
Exactly, yeah. Or the answer to your question is.
Right.
So it was drawing on those familiar question answering patterns.
Okay, so it's like it knows how to structure a response.
Yeah, exactly.
That's pretty clever.
It is pretty clever.
But for RAG, HD took a totally different approach.
It did, yeah.
What did it do there?
It mainly relied on the context-dependent database.
Okay, so DC in that case.
Yeah, so it was pulling in those repeated keywords and phrases right from that source text.
So it's almost like HD was acting like a smart copy-paste tool.
Yeah, kind of, yeah.
Like weaving together these relevant snippets.
Right, and that really highlights one of the most impressive things about HD. It's
Yeah.
adaptability. It doesn't just stick to one strategy.
Right.
It analyzes the task and then adjusts its approach to make the most of those three databases.
It's almost like HD has this sixth sense for language.
Yeah, it's like it understands how language works.
Yeah, it's not just speeding things up. It's like
Yeah.
it understands what it's doing.
Exactly.
That's really cool.
Yeah, and that's why I think HD is such a big deal in the world of LLMs.
Oh,
You
right.
know, it's not just about brute force speed.
Right.
It's about building a deeper understanding of language
Okay.
into these models.
It seems like we're on the verge of a major shift in how we interact with LLMs.
Yeah, I think so too.
I mean, with techniques like HV paving the way,
Uh-huh.
I mean, we could be looking at a future where LLMs are truly integrated into our daily lives,
Right.
providing us with instant information,
Yeah,
creative inspiration, maybe even a good laugh along the way.
definitely. Yeah. I mean, just imagine a world where language barriers are non-existent,
Right.
where personalized education is the norm,
Wow.
and where anyone can unleash their inner storyteller with the help of an AI assistant.
That's amazing.
It really is.
Okay, so before we wrap up, I want to kind of circle back to something that we talked about earlier.
Okay.
We talked about the power and the efficiency of HD,
Uh-huh.
but we got to remember that any technology,
Right.
no matter how beneficial,
Yeah.
comes with the responsibility to use it wisely.
Absolutely. It's up to all of us,
Yeah.
developers, researchers, policymakers, users,
Purpose.
everyone, yeah, to make sure that LLMs are developed and deployed ethically,
Uh-huh.
with a focus on fairness, transparency, and accountability.
Yeah, those are all important things to keep in mind.
Yeah, we need to be mindful of the potential biases and limitations of these technologies
Right.
and work together to, kind of mitigate any negative impacts.
So it's not just about what we can do,
Right.
it's about what we should do.
Exactly.
And on that note, I think it's time to wrap up our deep dive into hierarchy drafting.
Yeah.
You've really opened my eyes to this technology
Well, I'm glad to hear that.
and the exciting future it holds for LLM interactions.
Yeah, it's definitely an exciting field.
So thank you so much for joining us on this deep dive.
It's been my pleasure.
Until next time, keep exploring, keep learning, and keep pushing the boundaries of what's possible
Yeah,
with language and technology.
absolutely.